Hi guys, welcome back to another e-learning video. This video will be over the benefits of slope-intercept form and standard form and how to convert standard form to slope-intercept form. So let's start with slope-intercept form, the one you're probably more familiar with. The benefits are that it has a slope right away you can see and a y-intercept you can see right away. So it's y equals mx plus b. M is your slope, b is your y-intercept. So your slope's this coefficient. It's whatever's right in front of x. So you have 2/3 x, that means that 2/3 is your slope, and the other part here is your y-intercept, so your y-intercept is 4. So you can automatically just look at it and see, okay, the slope is this and the y-intercept is this. And this is just a friendly reminder of how you would graph it. So you would start with the y-intercept of 4. So you'd put a point on 4 for your y-intercept, and then you would go up 2 and right 3 for 2/3. And this is just a guide. So if you have a positive number up here, you go up. If you have a negative number here, you go down. On the bottom, if you have a positive number, you go right. If you have a negative number, you go left. So you'd go to 4, then you go up 2, right 3. Let's just random other example. If you had -2/3, you would go down because it's a negative, so you'd go down 2. And then this 3 positive, so right 3. So down 2, right 3. So that's how you would graph these. You always start at the y-intercept, and then you just follow the rules for where you would move to find the next point using your slope. And you can make the whole graph that way. So this gives you the entire graph, and so you got the slope and the y-intercept, and you can make the entire graph from that. So this is very, very good for us. This is easy for us to graph with. What about standard form? What are the benefits? So the benefits of standard form are that you can quickly tell what the x-intercept and y-intercept is. And so you'll notice that this does not tell us an x-intercept. It gives us the entire graph if we use the slope correctly and the y-intercept. So if we start with the y-intercept and then use the slope, it gives us the whole graph. But it's difficult to tell perfectly sometimes what the x-intercept is, even if you do all the work to graph the entire line. But this tells us right away, pretty much. We have to do like one step, then we can tell what the x-intercept is and tell what the y-intercept is. And I'll show you that just real quick. So let's try out, what if we put in 0 for x? Then you would just have 4y equals 28. So your y would equal 7. Oh, that's done really fast. So I can just look at this and go, let's say this is gone because I put a 0 in there. 4 times 7 makes 28. Okay, divide by 4, that's 7. Whatever way you want to think about that. This part is 7. So my y is 7, and my x is 0. This is my y-intercept. That was pretty easy to tell. I just kind of look at it and go, oh, 4 times 7 is 28. Done. And you can actually solve it out if you really want to. You can make a 0x 0 and show the elimination of that term when this is 0. And then divide by 4 and you get 7. Let's show it for the other one. Let's show it for when we plug in 0 for y. So let's say that y is 0. And you wanted to keep x. So you'd end up with just 7x equals 28. Because you're basically saying, okay, get rid of this because I'm putting in 0 for y, so this is just going to be a 0. So that's gone. And you just have 7x equals 28. So 7 times 4 is 28. Or you can divide by 7, whatever way you want to think about it. So x equals 4. So 7 times 4 is 28, so x equals 4. And then if we write that as a point, our x-intercept is 4, 0. So you can pretty quickly tell, let me get rid of this before it's not crossed out. You can pretty easily tell what the x-intercept and y-intercept is without even writing it out most times. You can just go, okay, 7 times 4 makes 28, so this is 4, 0, and then this is 4y equals 28. Okay, 7 would work right here, so 7, and then 0, 7. So you're basically just like, okay, pretend this is 0. Oh, it would have to be a 7. Okay, well, let's pretend this one's 0. Oh, that'd have to be a 4. So that's pretty easy to tell what the y-intercept and x-intercept are right off the bat. So it gives you that benefit for standard form. You can easily tell the x-intercept, whereas with slope-intercept form, you can't really do that. But in this case, if you were to graph this, and excuse my graph, it's going to be kind of shortened here. 1, 2, 3, 4. So you'd have, and let me kind of just circle so you can see where the point would be. Your point would be there for your x-intercept. And then your y-intercept, I'm going to need some more room. So I'm going to go ahead and move these and extend this. Okay, so 1, 2, 3, 4, 5, 6, 7. And let's do, say, blue. So you would have your y-intercept of 7 and your x-intercept of 4. And it'd be pretty easy to go ahead and make that graph. Here we go. Oh, excuse me. Make that a little straighter. Okay. This is approximately what your graph would look like. You can just go ahead and draw a line from there through there, and that straight line is your graph. So technically you've made a graph, and all you really needed to have is a y-intercept and an x-intercept. And you could figure out the slope from that. You could go, okay, I went down 7 and right 4. So you could figure out the slope from that. So I mean, once you have done a step where you actually do graph it, you could easily tell this, but that takes you making the graph before you will actually know the slope. So this tells you the slope right off the bat, whereas this, you would actually have to figure it out by yourself after graphing. And this tells you the y-intercept, and this one does as well, but this does not tell you the x-intercept, and this does tell you the x-intercept. But the problem with this is it's not going to be perfect every single time. It doesn't show you the little slope here sometimes. So sometimes this may need to be reduced to show you the smaller slope triangles that are in between. So you're going to have points that you're missing. So this tells you all the points you could have on the line if you do it correctly, whereas this does not. It tells you the y-intercept and x-intercept, and you can figure out the slope from that pretty easily. But that does not show you every point on the line. It's not going to be perfectly accurate, whereas this is. And then the last part of this video, I just wanted to go over how to convert from standard form. Excuse me, I accidentally brushed this. Let me make this go down just a little bit. There we go. Okay. So let's practice converting from standard form to slope-intercept form. Just real quick, just the basics of that, because we do want to graph things from using slope-intercept form. And I talked about why just a second ago in this video. So I would love for you to be able to graph this way, but this is the best way to graph because it does tell you the y-intercept, slope, and it tells you the whole line. I know it doesn't give you the x-intercept right away, but it's much better to graph with than standard form is. So we're going to convert from standard form to slope-intercept form, so it helps us out. So let's go ahead and do this. Slope-intercept form has y equals mx plus b, so we're solving for y. So I'm going to solve for y. I'm going to isolate y. I want y by itself, so 4y, subtract my 2x over, divide by 4. And remember to divide on every single term, not just one term. You got to divide 4 on everything. And then I'm left with y equals negative 2 fourths x plus 8 fourths. I just made this a y over here, and I will show you the simplification over here. Negative 1/2 x plus 2. So you simply just move your x over and then divide by whatever's in front of y to convert from standard form to slope-intercept form. I look forward to seeing you guys in live sessions and hearing from you during office hours.